Hi, I'm Ryan from PO5, and today I'll be explaining Euler's method, which is simple yet a powerful way to estimate solution to differential equation when we can't solve them exactly. I'll guide you through this method step by step using my own handwritten diagram, the formula of Euler's method, a clear explanation of process, and Excel spreadsheet that shows the full calculation, and also using general formula. So what is Euler method about? Euler method is the first order method that uses the first differentiative, which means it is to find the approximate value for the ordinary differential equation, or in short form, OD. So let's begin with this given problem. So dy dx x squared plus 1 divided by y, where y is more than 0. Given the initial value of y0 equal to 1, find the opposite value of y1, meaning that I want to find x, which is the unknown. So as you can see for my horizontal axis, it's actually split into x values. And then as for my vertical axis, it's actually split into 0.1, which is my step size. So the smooth curve, as you can see, represents the actual solution of the differential equation. However, since we're using Euler's method, we will approximate this curve using the straight line steps, which is shown by this straight line connecting the points. Each point represents the approximation of y at a specific x value. So now let's look at the formula behind Euler's method. So actually, this is at this is the Euler's method, or which is yn equal to yn minus 1 hf. H represents the step size. Then yn minus 1, which is also the previous. Yn minus 1 is the previous. So this is how I derive Euler's formula. Dy dx equal to y1 minus y0, x1 minus x0 divide. I will get the from Euler's method, and then the step size will be equal to h. So using this Euler's method, I'm able to actually calculate the values. So 0 plus 1, 0 taken from the last value, which is x, last x value, and then 0.1, which is my step size, 1 plus 0.1. So 1 represents the yn, then 0.1 represents the step size, and 0 square represents the x, previous x square, plus 1, which is already there, then divide by y, which is the previous one, also by n plus 1. And then this is continuously until we are able to get x10 equal to 1, which we are trying to find. So y10 is equal to 1.911375. But the thing is, how are we actually able to solve this? So in this derivative of slope as the previous point, in simple words, we take the previous y value and we add the value of the step size and the slope to get the new y value. In my diagram, you see how this formula works step by step, and we start from the initial point. Then we calculate y1 using this formula, y2, then y3, and then we keep repeating this process. And this process is called recursive because we keep using the most recent result to calculate the next. So one important thing that you need to notice is the approximation error. If you look at the gap between the straight line and the actual curve, you'll see that they don't always match perfectly. This difference between the actual curve and our straight line represents the error in our approximation. Usually the error becomes larger as we move further along the x-axis. To organize the calculation clearly, I created this table with three columns. The first column is my x value, which is my step size. The second column shows the approximate y value at each step, and the third column is my dy dx, helps to calculate the value in yn. This table makes it easier to keep track of how the values change with each step. Next, I transfer this process into Excel spreadsheet to speed up the calculation in Excel. I use this formula for xn. I use d5 e2, which is my d5, which is my previous, plus plus my step size over here. And after that, for my yn, I use f5 plus e5, which is using my x previous and y previous. And then for the dy dx, to help the calculation for yn, I use d6, which is my 0.1, and then square plus 1, divided by e6, which is my 1.1 over here, and then I use e2, which is my step size. So in the end, I will get the answer 1.911, because I want my xn to be equal to 1. Okay, x equal to 1. Then the general solution will be 1.91484. And how I get the general formula is actually using this calculation, using dy dx equal to x squared plus 1y, and I'm actually able to get 1.91484. And then for my approximate error to find it out, it's actually E7, which is my general solution previously when I calculated it, minus the E15, which is my answer for yn. Then afterwards, for my approximate error, general solution minus approx value. So to find the approx error, I use general solution minus approx value. Then at the same time, I try to lower my approximate value using the 0.5. Actually, by right, this is actually acceptable to use, but if I want to find a better approximation value, with 0.05, I get a smaller approximate error. This shows that the smaller the step size, the smaller the approximate error will be allowing for a more accurate answer to the general solution. So, uh, so overall, I show you how Euler's method works, from the handwritten diagram to deriving the formula, applying it step by step, demonstrate in Excel, and finally comparing it with the exact solution. Euler's method is a great way to approximate solution. It is quite easy to understand once you go through it step by step.